Hello friends, welcome to Zeta Axis, and today we will discuss about different types of volcanoes. We will discuss different types of magma, classification of volcanoes based on mode of eruption, based on period of eruption, based on their structure. We will discuss stratovolcanoes, caldera, lava domes, sealed volcanoes as well as cinder cones. So first let's see different types of magma. Magma type basically depends on two important properties. First is what was the source of the rocks which formed the magma, that is the rocks from which the magma was formed. The second important thing is rocks through which the magma has to travel to come to the surface from asthenosphere and the distance it has to travel. So let's see both of them in detail. The first is rocks from which the magma was formed. Now let's first consider mantle. We know that mantle lacks in silica content. So any magma that comes from mantle will have less silica content and therefore it will be basic in nature. Here you can see a mid-oceanic ridge. Magma from asthenosphere comes up and forms oceanic crust. This magma, because it comes from mantle, remember asthenosphere is also a part of mantle. So the magma that comes from mantle, it has less silica, therefore it is basic in nature. On the other hand, when we consider the earth crust, it has higher content of silica. Here we can see the distribution of elements in earth crust for both oceanic crust as well as continental crust. So we see here that there is a very high proportion of silica. Therefore, the magma which is generated by melting the rocks of earth crust have high silica content. We know that at the converging plates, if one of the plate is an oceanic plate, then certain volcanic activity occurs. At the subducting plate, we see formation of magma by melting of the rocks of the oceanic plate. This magma is not derived from asthenosphere, but it is formed by melting of the subducting plate rocks. Now, because silica content is higher in earth crust, we will see that the magma that is formed here has higher silica content. So this magma is more acidic compared to the magma that comes from the asthenosphere. Now let's see the second factor which affects the type of magma. This is basically the rocks through which the magma has to travel and the distance it has to travel to reach the surface of the earth. Now we know that magma has to travel through the earth crust to come to the surface. Here we can see this is asthenosphere and magma is traveling through the overlying earth crust to reach the surface of the earth. Here it's an oceanic crust. Oceanic crust has less silica compared to continental crust, and the thickness of oceanic crust is also very less. So what happens that the magma that rises here, it gets very less amount of silica added to it by the rocks which are melted from the oceanic crust, because oceanic crust is thin. So this magma which comes on the surface is basic. However, when we come here, when the thickness becomes more, we see that slowly from basic magma, the magma type changes to rhyolitic magma. Because as this magma rises up, it will melt the surrounding rocks. Silica melts first and it will be added to the upwelling magma. So the magma type is changed by the addition of rock melted by the magma, and therefore the higher the distance it will travel within the continental crust, more silica content will be added. So here we see, because the thickness is more than here, the magma that comes to the surface is andesitic. Here further we see that the thickness of continental crust is even higher. So the magma that reaches the surface is rhyolitic. So this is also one of an important factors on the type of magma that we see at the volcanoes. Now let's see comparison of all these three types of magma. Basaltic magma has 45 to 55% of silica, andesitic is around 55 to 65, while rhyolitic is 65 to 75. And we see that this kind of magma, when reaches the surface, it has to melt some amount of continental crust or oceanic crust. So the basaltic magma, it melts very low amount of continental crust, because if it melts more, then it will become acidic. The andesitic magma, which is an acidic magma, it melts the continental crust in medium amount, While the rhyolitic magma, which is very high acidic magma, it melts a large amount of continental crust before it reaches to the surface of our Earth. Temperature. We see that the basaltic magma is hottest magma because it has to travel least distance. Therefore, it loses less amount of heat in melting the overlying rock structures. So as we see here, the basalt has to travel very less distance. Its temperature is high when it reaches the surface. But andesitic has to travel larger distance. Therefore, its temperature is intermediate between basaltic and rhyolitic. While rhyolitic magma has to travel the greatest distance to reach the surface of our Earth. Therefore, its temperature is least in these three. Viscosity, again we know that as the silica content increases in a magma, the viscosity also increases. So we see basaltic is least viscous, andesitic is medium, while rhyolitic is high because the silica content is increasing. Composition. We know that the magma here is mafic in nature. So the basaltic magma is mafic. Andesitic is intermediate between mafic and felsic. It can be called felsic sometime. However, rhyolitic magma is completely felsic. Eruptions. We know that less viscous magma has smooth eruptions, while high viscous magma has explosive eruptions. Andesitic also has medium amount of explosive eruptions. Now let's see classification of volcanoes based on mode of eruption. Now based on the mode of eruption, we can classify volcanoes into two types, central type volcanoes and fissure type volcanoes. Let's see both of them one by one. A central type volcano is a volcano where there lies a vent. Magma comes to the surface through this vent and it is poured on a surface from this crater. So it comes through a pipe-like structure. This is called a vent. The lava here is generally viscous and acidic, and the eruptions are with huge blasts or mild blasts. So there are explosive eruptions because we know that acidic magma is viscous and viscous magma has explosive eruptions. The magma which is poured out here, it does not travel far because it is viscous in nature. So therefore you can see that it is generally conical in shape. Erupting materials can include acids, gases, vapor, volcanic dust and pyroclasts. Stratovolcanoes and lava domes are most common type of volcanoes having this structure. Mount Stromboli and Vesuvius mountains are also an example of this. Now let's see fissure type volcano. A fissure type volcano is a volcano where there lies a fault in the earth's surface and magma comes on the surface through this fault. So unlike earlier where there was a vent, a pipe-like structure, here there is a very large fault. The magma that comes out here is basic in nature, therefore that is very less viscous and therefore we do not have blasts here. The lava comes out very smoothly and flows to greater distance because it has very low viscosity. Therefore it is very easily fluid in nature. The lava when solidifies, it basically forms basaltic rocks. Our volcanoes of Iceland, which are located over mid-oceanic ridge, is an example of these kind of volcanoes. Moreover, on continental crust, these kind of volcanoes can form flood basalt, where there are several cycles of eruption and layers upon layers of magma is deposited to form a raised structure. Our Deccan Plateau is an example of flood basalt plain. Let's see classification of volcanoes based on period of eruption. Based on period of eruption, we can classify volcanoes into three types. The first is volcanoes that have recently erupted or they continue to emit volcanoes, like Mount Stromboli, like Mount Vesuvius. We know they are active volcanoes, they can erupt any moment. The second is dormant volcanoes. Dormant volcanoes are the volcanoes which have erupted in recent human history, but this was long ago. There is a very long time since which they have not erupted, but they show signs of volcanism. Our barren island volcano of Andaman and Nicobar was considered a dormant volcano, but it erupted in 1999 and 2017. Therefore, it was again classified as active volcano. The third type is extinct volcanoes. Extinct volcanoes are the volcanoes which show no signs of volcanism and they have not erupted in a very long time. Now let's see classification of volcanoes based on their structure. Based on the structure, we can classify volcanoes into different types. First is stratovolcanoes, caldera, lava domes, sealed volcanoes, and cinder cones. Let's see each of them one by one. We will begin with stratovolcano. Stratovolcano or composite volcanoes are the volcanoes which are formed due to regular deposition of tephra and magma. Here there is repeated cycles of eruption, and each cycle deposits a layer of tephra and magma. Here we can see that the darker lines are the tephra, that is volcanic rocks deposition, and upon it we can see a deposition of magma. And this repeated deposition leads to a very high structure of mountain. So the stratovolcanoes are very tall volcanic mountains. Stratovolcanoes are also called composite volcanoes because they are made of different layers of lava placed one upon each other, and there are different materials in it. Strato word itself means layered, and it is formed due to accumulation of tephra and lava over several cycles of eruption. We can see here that this is a layered structure. There are layers of tephra and magma which are repeated by different cycles of eruption. We can see that the volcano has conical shape and it has a very steep slope. The reason why it has a steep slope is because it is made of acidic lava. Acidic lava has high viscosity, and therefore this lava refuses to flow away. Moreover, viscous lava is known to have explosive eruptions. Therefore, these kind of volcanoes erupt with huge explosions. Now, the stratovolcanoes are mostly found around subduction zones where one of the oceanic plate is subducting. Now, we know when an oceanic plate subducts, the rocks of the oceanic plate are melted to form magma. This magma, when reaches on the surface, it forms stratovolcanoes. Now here the supply of magma is low because the magma is not coming from asthenosphere. It comes from melting of the subducting plate, and this process is slow because the plates move at very slow speed. The magma generated is also in a very less amount. These kind of volcanoes have shorter lifespan because it depends on the subduction of the plates. Once the subduction process is completed, that is, plate is completely subducted, there will be no supply of magma. In fact, even if there is a change in the direction of convection cell, then this process will stop. These are the most common type of volcanoes found in the world. In fact, almost 60% of the volcanoes around the world are stratovolcanoes. These are also the tallest volcanoes in the world because of the different layer formations. They could extend to several hundred meters. Barren Island of India and Vesuvius and Stromboli are example of stratovolcanoes. This is a Mount St. Helens in East Caribbean island. This is a stratovolcano, and you can see the steep slopes on the side. This is a real topographical image of the Mount St. Helens. Here we can see that there is a crater, and this is the direction in which the lava flows. Now let's see another type of volcanic mountain which we call caldera. Caldera can be formed from sealed volcano or stratovolcano. They can be acidic or basic. It is formed when due to huge eruption all of the magma is thrown out and this magma chamber becomes empty. It cannot bear the weight of the overlying structure and whole weight collapses. We see a crater is formed. This crater is generally circular in shape. You can see here that we have a crater which is almost circular in shape, and over time water will fill it and it will form crater. Now let's see the caldera formation in detail. So strong explosive eruptions can empty the magma chamber. The emptied magma chamber is not able to support overlying structure. As we have seen in the animation, the overlying structure collapses due to its weight. Magma chamber can be emptied in single explosions or chain of explosions. So we have seen that the magma chamber is emptied in a single or multiple explosions, and because it is empty, it cannot bear the weight of the overlying mountain, and therefore the whole mountain collapses under its own weight. A circular depression is created. This depression gets filled by water and it is called crater lake. They can be several kilometers big. You have seen that a circular crater is formed when the whole mountain collapses. and when water is filled, we call it crater-like. The caldera can be formed by collapse of crater of a stratovolcano or sealed volcano, or even it can be formed from new eruptions as well. The caldera can be acidic or basic type. The example of acidic caldera is Lake Toba in Sumatra, and the example of basic caldera is Kilauea caldera in Hawaii. Calderas are not very common and they are very rarely formed. Lake Tabo of Sumatra is an example of caldera. Here we can see Lake Tabo of Sumatra. You can see here that there is a depression, and in the middle there is a raised part, there is an island. This is filled with water. So this is a crater which is formed by a caldera, that is collapse of the volcanic mountain due to an empty magma chamber. Now let's see another volcanic structure called lava domes. Lava domes are formed by very acidic magma, and because this acidic magma is very much viscous, it will not flow, but it will form one upon another. You can see here that we have a very high slope here, and it is not even conical, it is like a dome shaped. So this kind of structure is formed in lava domes. Lava domes are not very big in their size. Let's see lava domes in detail. So they are formed by very viscous lava. Lava does not flow but pile up, forming dome structure. So we know that lava domes are formed of viscous lava, and they do not flow but they pile upon each other. They are very small in size, and they are generally formed in crater of larger volcanoes. You can see here, this is St. Helens mountain which we have seen. This is the volcanic crater of that mountain, and within this you can see this is our lava dome. You can see that lava domes are formed within the crater of other volcanoes, and they are generally acidic type. Then let's see sealed volcanoes. Sealed volcanoes, like stratovolcanoes, are formed by different cycles of eruption. In each cycle, lava and tephra layers are deposited upon each other, forming a very giant structure. So you can see here that we have different layers of tephra and magma. Now, unlike stratovolcanoes, they are not very high and they do not have steep slopes, but they are very large. They are expanded in very large distance, and they have very smooth slope. You can see here. So sealed volcanoes are formed of basaltic lava, that is, they are formed of basic lava. Now basic lava is less viscous, therefore it can easily flow to large distances, and that is why it forms gentle slope. It is formed by layers of lava and tephra, which we have already discussed. They cover very large area and they can be very high, but they are not higher than stratovolcanoes. They are generally found along hotspots or oceanic island areas. In this hotspot, the lava comes from very deep part of our earth, and that is why it is very basic in nature. They have a very long life because the supply of magma is from the asthenosphere or mantle, and they have large amount of magma supply. So we have already seen, because the magma comes from the asthenosphere, it can last for very long, as well as the supply is also very high. Hawaiian volcanoes are example of sealed volcanoes. Now here we see a topographic image of a Hawaiian volcano, and you can see here that compared to stratovolcano, the slopes are very smooth. You can see that there is a gentle slope. Stratovolcano would be something like this, where it would have a very steep slope, but here the slope is very gentle and it is spread in a very large area. Now let's see cinder cone volcanoes. Cinder cone volcanoes are formed by cinders. Cinders are volcanic rock fragments. Therefore, the cinder volcanoes are not layered, and you can see here that there is no formation of layer. They are generally formed in single or couple of eruption cycles. They are mid to high in height range. Let's see it in detail. Cinder is equal to pyroclastic fragments. So we have seen that they are formed of rock fragments. They do not have layered structure, as we have already discussed and seen in the animation. They are also conical in shape. These volcanoes are bigger than lava domes, but they are small compared to shield and stratovolcanoes. And they are formed along with any other type of volcanoes. That is, cinder cones are generally not formed alone, but they are formed along with certain other big volcanoes. You can see that they are formed on flanks, that is on sides or vents of other volcanoes. They are formed generally on basaltic kind of magma, but sometimes they can be andesitic magma that forms cinder cones. They have round crater at top. So the lava, when it comes out, it forms a round crater. Here is an example of cinder cone. We can see that the crater is circular in shape. Now let's summarize all the volcano types based on the structure that we have discussed. So we have seen stratovolcano, caldera, lava dome, shield volcanoes and cinder cones. So the type of lava that makes these volcanoes is acidic for strato. Caldera can be acidic and basic, but generally it is acidic. Lava domes are almost always acidic. Shield volcanoes are always basic, and cinder cones can also be both basic and acidic, but generally they are basic magma which forms cinder cones. Stratovolcanoes are very large. Caldera is also very large. Lava domes are very small. Shield volcanoes can also be very large, while cinder cones are small to medium size. If you look at the shape, stratovolcanoes are conical in shape. The caldera has large circular shape because of the collapse of the mountain. Lava domes are dome shaped. We have seen a dome shape which is not exactly conical but something like this. Shield volcanoes are shaped like shield, that is, they have a very gentle slope, something like this. The slope is very gentle. While cinder cones are also conical shaped. Stratovolcanoes are layered. Caldera can be layered if it is formed of stratovolcano. Lava domes are not layered. Shield volcanoes are layered. Cinder cones again are not layered. Now we know that volcanoes which have acidic magma, they erupt with blasts, or there is a violent eruption. Stratovolcanoes have acidic magma, eruption is violent. Caldera, when it has acidic magma, it will have violent eruption, otherwise smooth. Lava domes have acidic magma, therefore the eruption is violent. Again, shield volcanoes have basic magma, therefore the eruption is smooth. Cinder cones have basic or acidic magma, therefore they could be violent or smooth eruption based on the type of magma. If we see the location, stratovolcanoes are generally formed along the subduction zones. Lava domes are formed in the craters of other volcanoes. Shield volcanoes are generally created on hotspots or oceanic islands because it is formed by basic magma. And cinder cones are formed on the flanks of bigger volcanoes. This is the whole table. If you want, you can note it down. Thanks for watching the video, and if you like the video, please like, subscribe and share. If you like our effort and like what we are doing, then you can use our UPI ID or Patreon ID to support us. You can follow us on our social media links. Until then, we meet again. Jai Bharat, Jai Gyan. Thank you.